Hey guys, what is up people? How are you people doing? Welcome back to today's session. Hoping that all of you guys are doing good and taking very good care of yourself. This is a session number 2 of Light, where we'll be talking about the focus of both a concave mirror and as well as a convex mirror as well. So my name is Anoop and welcome back to today's session. So today guys, we'll be focusing on focus. That's what we're going to talk about. So as always guys, we'll start off with the quote and then get started with today's session. The quote for today is this guys: I know that I'm on the right path because things stop being easy. Here's the thing guys, life is not a bed of roses, and you've heard this thousands of times and you know it by now. But one more fact is that if you're not challenging yourself, you're not growing. So always challenge yourself. Be a better version of yourself. No matter what field you are, you want to be an expert in, you have to keep challenging yourself. When things get easy, that means your point of saturation has reached. So there's no more growth. Always try to explore yourself. Always try to be better at whatever trade you're at. So that is my advice to you people. With that said guys, let us get started with today's session, which in the last session we talked about spherical mirrors and its components. We talked about what is a concave mirror, convex mirror, what is the center of curvature, the radius of curvature. We talked about the pole, the principal axis and whatnot. All the components we have discussed that in the last session. So if you haven't watched the video of that already, please go and watch the video of that so that you understand things better, or you're able to relate to whatever we're saying we're going to be studying in today's session. So people, let us start with focus. Now before that, in the last session, spherical mirrors and its component, I'd given you a homework. It was a very simple question. The question was this: straight line passing through the center of curvature and pole is called as what? What is a straight line which passes through the center of curvature as well as the pole? Very simple guys. It is the principal axis. It is the straight line which passes through the center of curvature as well as the pole. It has nothing but the principal axis. Very simple question, very simple answer. Hats off to all those guys who gave the right answer for this one. With that said, let's talk about the focus of a concave mirror. Then we'll understand about the focus of a convex mirror as well. So starting with the concave mirror guys. Now you know that concave mirror is nothing but a mirror which has the reflecting surface curved inwards. It is curved inwards. So let's say that there's a ray of light coming from infinity and falling on this spherical mirror. I know from some distance, x distance. I don't know what is the distance. So from some x distance from infinity, it is coming and falling on this spherical mirror. That is the incident ray. Obviously, you have when a ray of light is falling on a surface, you have incident ray, normal, and the reflected ray. Now in the last sessions, in your past grades, you have understood what is the angle of incidence. Angle of incidence is what? The angle formed between the normal and the incident ray. And what is the angle of reflection? The angle formed between the normal and the reflected ray is nothing but the angle of reflection. You already know about all of these. So in a plane mirror guys, and the normal is what? It's a perpendicular line or a straight line which makes 90 degrees with the surface. That is what is called as a normal. But a spherical mirror is curved. So how do I draw, or how do I get this 90 degrees on a spherical mirror? Let's understand that. Now in the last session I told you that a spherical mirror is actually a part of a sphere. It's actually a part of a bigger glass ball. So let's take a 2D structure of that sphere, which is nothing but a circle. Now what I'm going to do is that to find out the normal of this, or normal at a particular point, what I can do is draw a tangent. Now what is a tangent? You guys know about it. Tangent is nothing but a straight line which basically touches one point on the circumference of the circle. That is what is a tangent. So it's a straight line which touches one point on the circumference of the circle. So here that point is nothing but P. O is nothing but the center of the circle, or the center of that particular sphere, the center of curvature of a glass sphere, or that spherical mirror. Now the normal for a spherical mirror is nothing but a straight line perpendicular to the tangent and is passing through the center of the circle. So basically a line which looks like this. So no matter where the tangent is, let's say I take the tangent over here. Alright, my tangents are pretty bad. 1 second guys. Yes. Alright, so let's say I take a point over here. Alright, so straight line perpendicular to this tangent which is passing through or is touching the center of the circle. That, my friends, is what is basically the normal of a spherical mirror. So on that point, basically the normal of that particular on that particular point, wherever the incident ray is meeting, or wherever the incident ray is touching that spherical mirror, that point, the normal would basically look like this. It's basically passing through the center of curvature. As simple as that. Now, this angle here is nothing but I, which is nothing but the angle of incidence, right? It is the angle of incidence. That is the normal, that is the incident ray. So the angle formed between them is the angle of incidence. Now, in your past grades, you've always studied this, that a ray of light will always follow two laws of reflection. The first law of reflection is that the incident ray, the reflected ray, and the normal all lie on the same plane. The second law of reflection is that the angle of incidence would always be equal to the angle of reflection. So if the angle of incidence is I, the same angle should be formed between the reflected ray and the normal. So basically it should look something like this. The angle of incidence and the angle of reflection should be exactly the same. So if I draw a line with that particular angle in mind, I would get a reflected ray which it looks like this, which cuts the principal axis at this point. Awesome. Now let me take another incident ray. All right, another incident ray which is coming from infinity again. Again, I'm going to draw a normal. And again, when I draw the reflected ray, it is also meeting at the exact same point on the principal axis. Now, no matter how many rays I take, every ray of light which is parallel to the principal axis, you see this, all of these rays of light are parallel to the principal axis. All these rays of light which is coming from infinity parallel to the principal axis, after reflection will end up meeting at the exact same point on the principal axis. This point, my friends, is what is called as the focus, and it is denoted by the capital letter F. Now, the thing about a concave mirror is this, guys. You see this, all the rays of light, they're all parallel to each other. But after reflection, they're all meeting at a point. So it's called as a converging lens. It's called as a converging mirror, not a lens. A converging mirror, because all the rays of light are after reflection, they are all meeting at a same point, or they're converging and meeting at the same time, and that's what the same point. That's why it's called as a converging mirror. And the focus is a point at which the rays of light meets after reflection. When you talk about a concave mirror, it is in front of the mirror itself. But people, a convex mirror is a little different. So let's talk about what does the focus of a convex mirror look like. So a convex mirror is nothing but this, where the reflecting surface is towards the outside. So let's take a ray of light which is coming from infinity, coming and hitting the surface. So I draw a normal which basically looks like this, a straight line. Now remember this, in the last session I told you, in a convex mirror, the center of curvature lies behind the reflecting surface, or behind the mirror. So this is where the center of curvature is. So when you draw a line which passes through the center of curvature, and if you draw a tangent, this is the normal that you get. So this is what is the normal. So that dotted line, that represents the normal. So if I find out the angle between the normal and the incident ray, I'll get I. And the same angle, if I use it to find out R, that is what is my reflected ray. Now, let's take another ray of light. All right. Any ray of light which is again parallel to the principal axis, when it hits a convex mirror, it hits the surface and diverges away. It spreads out after reflection. It is not meeting at a point. It is all spreading out, and that's why it's called as a diverging mirror, because after reflection, they are going away from each other. They're not coming and meeting at a point. They're actually going away. They are taking their own path and they're going away from each other. That's why it's called as a diverging mirror. But here's the thing, guys. According to the person who's seeing it, where will be the focus of this? So if you what the image actually looks like. So when you're looking at the image, it appears like the image is actually coming from behind the mirror. It actually looks like the object is behind the mirror, because the focus of a convex mirror would actually lie behind the mirror, and because of this, all of the when you're basically what happens is that when you're standing at that particular point, you see that for an observer, that rays of light actually start to emerge, or basically it appears to meet at that point. So when you extend that ray of light, when you extend it, it appears to meet at a point on the principal axis, which is the focus of a convex mirror. So here's the thing, guys. The major difference is that in a concave mirror, the focus is actually where the rays of light are meeting. But in a convex mirror, the focus is the point where the rays of light appear to meet. They're not actually meeting. They're actually diverging away from each other and going. But then it appears like the point, the image or the object is originating at that particular point, and so that becomes the focus of that particular mirror. And the focus in a convex mirror lies behind the mirror, not in front of it. To an observer, it appears that the rays of light are originating from that point when he and it appears like it is when he's standing from a point behind that mirror, and that is what is called as a focus. Now now that you understood the case, let's sum it all up. In a concave mirror, focus is in front of the mirror, and that is the real focus because the rays of light are actually meeting at the point. In a convex mirror, on the other hand, the focus is behind the mirror, and it's a virtual focus because it's not actually meeting at that point, but it is only appearing to meet at that particular point, and that's why it's called as a virtual focus. Now to talk about what is the relationship between the radius of curvature and the focus. Now here's the thing, guys. First of all, what is the focus? Focus is nothing but a point on the principal axis where the rays of light are actually meeting. When you talk about a concave mirror and in a convex mirror where they're appearing to meet. So basically this is the focus for both these mirrors, and that is the center of curvature. Now this distance from the pole to the center of curvature is nothing but the radius of curvature, because radius, see, if that is the center of the sphere, obviously that distance to that particular point would be nothing but the radius. So that is nothing but the radius of curvature. Very simple, which is denoted by r. For both the spherical mirror, that is the radius of curvature. Now, at the same time, we also have focus, right? This distance from the pole to the focus is called as the focal length of that particular mirror. What is the focal length? The distance between the pole and the focus. What is the distance between them? That is the focal length. Now, if you look at them, this is what it looks like. So basically, f is the focal length, small f is the focal length, capital F is the focus, C is the center of curvature, R is the radius of curvature. So if you look at it, guys, what you understand is that mathematically you can say that the focal length of a lens or of a mirror, is going to be half that of the radius of curvature. Basically, what I'm trying to say is that F is equal to R by 2. The focal length is half that of the radius of curvature of a particular mirror. So it will be R by 2. So if you want to find out R, which is the radius of curvature, it is nothing but 2F. Twice that of the focus. As simple as that. So that pretty much concludes the topic for today, guys. That is all I had to teach. But before we solve the questions, I have an important announcement to make. I know many of you guys already know about it. So just give me 2 or 3 minutes of your time and then we'll solve the questions as well. So here's the thing, guys. We had done a survey based on which we got a lot of information about what are the problems that you guys are facing in your studies day to day, especially because of the quarantine that is going on right now. So here's the thing, guys. Few of the things that you guys told, and I'm pretty sure that all of you guys will be able to relate to this. First is that, sir, my doubts are not getting cleared. That is a very big problem, right? Secondly, I'm not getting enough my notes. Whatever I'm studying in the online classes, the notes that I'm getting is not enough. Third problem that you guys are facing is tests and assignments. How do I practice for my final exams? Where do I get the questions to practice and make myself better? Competitive exams. How do I train myself for competitive exams like NSOs, KUPY, NTSE, all kinds of competitive exams that you guys are planning to take up? Choice of your own schedule, because you're not free when the teacher is free. When teacher is free, you're not free. That is a very big problem that you guys are facing. And finally, choice of your own language as well, because some of you guys understand Hindi better, some of you guys understand English better. Now here's the thing, guys. We at Vedantu have solved all of these problems, starting with the doubts. In the class, you'll not just have one teacher, you'll have 2 teachers. One is the master teacher who will be teaching you the concepts, and you'll also have the class teacher to help you clear your doubts as well. So basically your doubts are getting cleared inside the class right away, and basically you'll be getting personalized attention because of this. You can download all the notes and watch the recordings n number of times, how many times that you want. You can watch the recordings and download the notes of each and every class. You can you have periodic tests and assignments to check where you're going wrong, what are the things to improve yourself. So you have periodic tests and assignments, and based on those tests and assignments, you would also be getting a personalized report card as well, which tells you what are the topics that you have to where you have to get better. You'll also be trained for competitive exams. You can choose your own schedule, whichever schedule you feel like you want to study in. You can choose that time and study at that particular time. and you can choose your own language. Now here's the thing is, language, we are offering classes in both English as well as in Hindi. Other languages are not there as of now, but majority of the country understand Hindi and English, so that problem is also solved by that. So here's the thing guys, together with that, you'll also have a lot of bonus that you can watch. How many of your live classes you want, there's no limit to it. You can watch 10, 20, 24, how many of your live classes you want, you can watch that in a particular day. You have all micro courses and crash courses for free of cost with the performance report card, like I told you, when you take those tests and assignments, and you get personalized attention as well. So what you have to do is very simple guys, visit this website vdnt.in/ytpro. Once you visit this website, this is what you're going to get. You have to choose which grade are you in, from 1 to 12th grade. So let's say that you are in 10th grade. Once you click on 10th grade, they'll ask you which board are you in, CBSE, ICSE or Maharashtra board. Let's say that you're someone in CBSE syllabus. If you click on CBSE, this is what you're going to get. Whatever I told you, everything in one glance. You can pause the video and read each and every one of these. Now, what you do is click on get subscription. Once you click on get subscription, this is what you're going to get, 1, 3 or 6. Let's say that you want to try out for the next 30 days. That is a 1-month subscription course. The base price of that is 4,000 rupees. But you get a primary discount without any kind of coupon code to about 2,699 rupees. And once you click on enter coupon code and enter this coupon code AKPro, you'll get an additional 400 rupees discount. Essentially, you'll be paying just 2,294 rupees for a month. Let's say that you want to try out a 3 months course. 3 month, the basic course is, the base price is 10,000 rupees. You get a primary discount of about 3,000 rupees, making the price to be 6,999 rupees. And once again, if you enter the coupon code AKPro, you'll get another additional 1,049 rupees discount. Essentially, you'll be paying 5,949 rupees. Let's say you want to try out the 6-month course. For the 6 month course, the base price is 16,000 rupees. You get a primary discount of about 4,000 to 5,000 rupees. Essentially, you'll be paying 11,499 rupees. If you enter the coupon code, you'll get an additional 700 rupees discount. Essentially, you'll be paying 9,774 rupees. So do check it out, guys. What you have to do is very simple. Visit this website vdnt.in/ytpro and the coupon code AKPro. I've told you all the advantages. Try it out and let me know what you think about it. With that said, let us get back into the question and answers, the all awaited question answers. Now again guys, I want all of you guys to write down the answers in the comment section below. Let me know how was the session, and also let me know what are the topics that you guys are finding hard, so that I can focus on that in the upcoming sessions as well. So here's the first question, people. A normal at any point of a spherical mirror passes through what? The pole, the focus, the center of curvature, or all of the above. Now I want you guys to write down the answer in the comment section below. Here's the question. A normal at any point on a spherical mirror passes through the pole, the focus, the center of curvature, or none of the above. The answer to this question, you know guys, it's option number C. It is the center of curvature. Like I told you, you have to draw a tangent first, draw a perpendicular line to the tangent, and that line should pass through the center of curvature. Then you can call it as the normal of that particular point, at that particular point. Second question. A mirror has a radius 30 centimeter. What will be the focal length of the mirror? Is it 15 centimeters, 30 centimeters, 40 to 45 centimeters, or 60 centimeters? You know the answer for this one. What is it? Focus is nothing but, the focal length is equal to half of the radius. So radius is given as 30 divided by 2. So 215, you'll get as 15 centimeter. The focal length is, guys, 15 centimeter. Very simple. Comment section. Third question. Which of the following statement is not true about the concave mirror? Which of this is not true? Now I want you guys to pause the video and let me know what is the answer in the comment section, guys. Here's the question. Here are the options. Are all the parallel rays converge after reflection? In a concave mirror you're talking about, all the parallel rays meet at the same point after reflection. All ray parallel to the principal axis pass through the center of curvature after reflection, or rays of light parallel to the principal axis meet at the focus. Which statement is not true about the concave mirror? The answer, guys, in 3, 2, 1, it is nothing but option number C, because it does not pass through the center of curvature, it passes through the focus. All rays do converge in a concave mirror. That is what's called as a converging mirror, and all rays of light will meet at the same point, and if they are parallel to each other, they'll meet at the focus. So option number C is definitely not the right answer. I mean, it is not the right statement. Here's the next one, guys. The fourth question. This was a board exam 2010 question. Here's the question. The outer surface of a hollow sphere, a sphere of aluminium of radius 50 centimeter is used as a mirror. What will be the focal length of its mirror? Which type of spherical mirror will it provide? 25 centimeters convex mirror, 100 centimeters convex mirror, 25 centimeters concave mirror, or 100 centimeters concave mirror. So the outer surface of the hollow so this is, imagine this is the sphere, all right? This is an aluminium sphere of radius 50 centimeters. So this radius is around 50 centimeter. Awesome. They're asking you what will be the focal length of the mirror and which type of spherical mirror if the outer surface is the reflecting surface. Is the outer surface. So this side is silvered then, this side is silvered then. So the outer surface would basically mean what the mirror would look like this, which means it's a convex mirror. So it's either option A or option number B. First thing, it's a convex mirror. Now, the focal length, you know the formula for this. What is the formula? F is equal to what? R by 2. R is 50 divided by 2. So we get it as 25 centimeter. So you know the answer, guys. It's option number A. That is 25 centimeters and it's a convex mirror. It's a diverging mirror, in other words. With that said, guys, here's your homework for today. If the radius of curvature of a convex mirror is 30 centimeters, what will be the focal length? Let me know what is the answer in the comment section below. I'll be hoping to see the answers as soon as the video is out. Thank you for joining, guys. That is it from my side. Like the video, subscribe to the channel, and I will see you in the next one. Take care of yourself. Catch you guys in the next session. Bye bye, people. Take care.